Hey, David. Mr. Fosnight, I got to tell you, you really need to see David's experiment. It really came out really well. Watch the video, and I'm giving you a shout out, David. That was awesome, and thank your mom for helping you on that. And it came out really cool. And what kind of cars have you been doing? It's just a good job on your project, David. You got it done real quick. You did a great job on everything, and I appreciate it. Appreciate you working hard. What kind of car models are you building? Some old hot rod classics and something fancy? A few from the 80s? Cool. Maybe a Camaro or Firebird or something, Corvette. Couple fancy Buicks. That's awesome. You got to be patient when you're doing models. You know, we had a model club last year. We didn't have it this year. We didn't have clubs the same we did last year, but we were building models. That would have really been cool to. We each had a car to build, and I got to build one. Matter of fact, when we come back to school in the fall, I'll have to show you the car that I did. You'll enjoy it. So I don't know who's going to join us today. It looks like it's just you, me, and Mr. Fosnight. I'm going to start off by telling you that this week is the last week we're going to be doing any live streams. Also, I don't need to tell you, you videotaped your experiment. You sent it to me. You did an awesome job. Now, word almost came out backwards. You did a great job. I really enjoyed watching it. And enjoyed watching your reaction when you got a different reaction than what you expected. I saw your sheet that you filled out. I mean, just did a great job. That's what you're supposed to be doing. And you know, I'll talk a little bit about scientific experiments in general, and just the idea that most of the time, when we're looking for something, like if a scientist is looking for an answer to something, most of the time, like over 90% of the time, their hypothesis is usually wrong. And so they have a hypothesis, like yours was multiple, right? Because we were talking about whether things float or whether they sink. And so you had to have some understanding about density, right? And how tightly packed in those little atoms are. Because I can have something that's this big, right? Hey, Lucas, this doesn't look very big. It's a thin little piece, okay? Or I can have something as big as this tissue box, okay? But guess what? This weighs a lot more than this. So you used your logic and you're thinking about, okay, is this going to float if I put it in water, or is this going to float? And my logic says, oh, this is really light and it's got a pretty big surface area. I think it'll probably float. This is super heavy. And because it's super heavy and a lot more heavier than the water, I think it's going to sink. And so we use our reasoning skills when we're trying to come up with a hypothesis. Plus, we can look things up that helps us, right, understand things. But sometimes we just make decisions based on what our background knowledge is. This bar of soap, this paper clip, this popsicle stick, whatever it is that we're using, and we put it in the water, for example, to see whether it flows. We use our background knowledge. I think I had experience with this before, and I think it's going to flow. Or something that same size, that's as heavy as that is, I think it's going to sink. And so you put all that information together and you come up with your hypothesis. And so part of the problem is our background knowledge isn't always correct. Sometimes it is, sometimes it isn't. And so even, we're talking about people that have gone to college and got college degrees, master degrees, even doctors who've gone to school for 8 years or more, become a doctor, and they're still doing experiments, and they're still coming up with hypotheses that are usually wrong. And so one thing that's really important, that's one of the things I loved about your experiment, because you were like, yeah, that's what I thought was going to happen. Yeah, that's what I thought was going to happen. Yeah, that's what I thought was going to happen. Oh, I didn't think that was going to happen. And so that's where the learning comes in, right? That's where you learn by getting a different answer than what you expected. Because what happens, it makes you start to think, why didn't I get the answer that I expected? Why did this object float instead of sink? What is the difference that made it sink and made it float? A lot of it has to do with how densely packed in the little atoms are. You could have this is really heavy for the size it is, this really heavy piece of metal, or you can have something like this balloon, okay, which is pretty big comparatively, right? It's a lot bigger. It's a heck of a lot lighter. And with static electricity, it's kind of sticking to me. Stay. Or we can have this box of tissue. It's chasing me. And this is still a lot lighter than this. And if I had to guess, I'd say this one's going to float because of its size comparatively and its mass. And so hopefully when you guys do an experiment like David did, hopefully that's where that learning comes in, okay? This isn't all about getting a grade. It's about the learning experience. What was cool about what I did? What did I learn? And that trial and error is how you learn it. By going through that experiment and saying, this is what I expect to happen, but I got a different result. Now I need to rethink, why did I think that? And how do I rethink it? And going back to what I said, people who do experiments as a profession, like doctors and scientists, even chemists, they're wrong a lot of the time. I mean, a lot of the time. I had a friend who was a chemist, and he worked for an oil company, and they were always doing experiments all the time. And he said almost all the time when they did an experiment, they were wrong. They didn't get the result they were trying to get. And so it's okay to just remember, it's okay to be wrong, because that's what the learning goes on. When you're wrong, it makes you go, okay, what did I do wrong? What was I thinking wrong? How do I correct it? Those skills, that deep thinking skills, those are something you can take outside of science class, right? Reasoning skills, okay? Why did this happen? Reasoning skills are something you can take with you no matter what you're trying to figure out. Maybe you had $100 and it's gone. Why did I lose my $100? Was it because I played $100 in the lottery? Was it because I had to put it in my gas tank because I'm driving all over town? Was it because I bought everybody I know food? Was it because I have a hole in my pocket and it fell out? Was it because somebody stole it from me? Reasoning skills, whenever we're doing something, it's really awesome to get those reasoning skills. And something just caught my eye here. And develop those reasoning skills into something that you can use not just in science but outside of science. All right, so let's get back to the basics of our project. I know, Lucas, you were doing yours, and David, you got yours done. Thank you. Just remember all those steps that you had to go. You ask a question, you use any background research and that could be just what you have in your head, and you come up with a hypothesis. Which cinnamon roll do I think is going to come out the best using 3 different formulas? Okay, and you take a guess, and then you find out maybe you were wrong, maybe you were right, maybe you were wrong. But let's assume that you were wrong. Why didn't this first batch of cinnamon rolls that I made, why didn't they come out? What caused it to have an adverse result? What caused it to taste bad or look bad or feel bad or not rise up or whatever? And so that's, Lucas, that's where the learning goes on. Once you've made a mistake, you learn how to do it right. Like when we learn how to ride a bike or get on a skateboard or a hoverboard or anything like that. How do we do it? Yeah, we fall a few times, right? How do we learn to swim? By getting in the water and doing it. And so this trial and error that goes on in a scientific experiment, you cannot think of it as success or failure. Because if you have that mentality, you're going to go, I can't do this. You guys, especially you, David, the video I've seen so far is, what did I see? I saw you work through it. Even when you had a wrong answer, you just kept going. And that's awesome. That's everybody needs to be that way, to say, yeah, I can be wrong. I tell you what, Mr. Soriani's wrong a lot. We all make mistakes every single day, and in science, when we're trying to find an answer to something, it's not whether we're right or wrong. It's whether we've learned through the process. What do? We take that little extra piece of information and we add it to what's in our brain, and we come up with a new hypothesis or a new guess. And we try it again. And if it fails, we come back and we try it again. And if it fails, we come back and try it again until we get it right, or until we get it as close to possible as we can. I mean, it's awesome that we can do that and see that. We can see it in the world, that if anybody follows the space program, all these private companies are doing launches. And if you go back and look at some of their early launches, explosion on the launch pad, or trying to have the fuselage come back down so they can reuse it, and it crashes on landing, all this kind of stuff that happens, that they finally figured out how to make it work right. And so hopefully what I want you to get out of this is just don't be afraid to fail. Because when you fail, you learn from it. When you're learning to ride a bike, when you fall, hopefully you're saying, okay, now that I've fallen, I know how to stay up, because I know what I did right and I know what I did wrong. I know that I need to have my balance, and I know that I need to keep pedaling. And when I want to stop, I know I need to either put my brakes on like this with the handlebars or with my feet. And so always be willing to keep learning, and understand that if you make a mistake, mistake doesn't equal failure, and mistake doesn't equal, I hate to say the word, I don't even want to use it, but failure doesn't equal that you're dumb or anything like that, okay? All that means is you've tried and you didn't get the right answer, so you try again. And so time and time again, you'll do this. When you come back in the fall, we'll be doing experiments again. And you guys know this process. You've learned this process. You've done it. And when we come back in the fall, we're going to do it all over again. And then we'll start integrating it into the things that we learn so that we can have successful science experiments for you guys. The more you get earlier, the better. If you guys have any questions about any of your writing part or anything, if I have any questions, I will send you a message. If you feel like you've sent me something and it's fine, if you haven't heard back from me, that usually means that it's fine. If I get something from you and I don't understand it, I'll let you know. I've checked my email quite a bit. Since it's just the two of you guys, I don't think anyone else is on. If you don't have any questions, we're going to cut out a little bit early today because for you guys, this is review. For you guys, you're on top of things, and I appreciate that. So if you don't have any questions, which it doesn't look like you do, we can cut her out a little bit early. I hope you guys are having a great day. So we're going to early cut out today. Love you guys. This is our last week of streaming. We'll see you on Thursday and talk to you soon. Bye-bye.